So I am going to start with equilibrium. Okay. In this chapter, I will discuss the concept of equilibrium. And second thing, I will discuss how to write Kc and Kp. This is basically, equilibrium constant, means you can say expression of equilibrium, you can say. And third condition, I will discuss Leach-Eterle principle. And one more thing, law of mass action. So let's start the concept of equilibrium first. So what is equilibrium? Equilibrium means it is a state at which, we can say it is a state at which some measurable property, measurable means like temperature, pressure, volume, concentration, remains constant. This is equilibrium. Means during passage of time, these parameter will remain unchanged. And to behalf of equilibrium, concept of equilibrium, we can categorize our reaction in two types. The one, reversible. Second, irreversible. So first I am going to discuss the concept of reversible reaction. So reversible reaction is basically bidirectional, means like this. Means we can say reactant and product. The left hand side is your reactant, right hand side is your product. So we can say both are interconvertible. Interconvertible means reactant can convert into product and product can convert into reactant. And second point is equilibrium is defined for reversible reaction. Reversible. And third point is it is carried out in closed container. Closed container. And in irreversible reaction, suppose I am saying A to B. I am saying my reaction is A to B. So this is monodirectional. Mono means unidirectional. It only be reactant to product. So it is, we cannot say like it is interconvertible, and equilibrium is not defined for this. No equilibrium for irreversible reaction. And it is carried out in open container. Open container. So this is the concept of reversible and irreversible reaction. Okay. So if you want to write, or you can take the screenshot of this, because I will not provide you the time to write down this. So you can take a screenshot and we can move forward. Okay, perfect. Now I'm going to tell you about the graph of equilibrium. Suppose we have a chemical reaction A to B. And one more thing I want to tell you. If you will write the equilibrium constant K, then it is a concentration of product upon concentration of reactant. And you can see B is my product, A is my reactant. So we can say it will be K equilibrium, it will be B divided by A. Okay. So suppose I am going to make the graph. This is the graph, suppose. You can see in a very starting of reaction, you can see reactant always has higher number of concentration. So this is my A. And just at initial point means when reaction will start, your product will become 0. So this is my B. This is my B. And means at a very starting point, product is 0 and reactant has few more concentration of moles, we can say. And after few time, you can see from here, at this point, the concentration of both become equal, you can see. And this is the time of equilibrium when both concentration become equal. And you can see this is time and this is concentration. So you can see during the passes of time, the concentration of reactant will decrease and product will increase. But in case of equilibrium, the rate of change of A and B both are equal. Means the rate of decrease of A and rate of increase of B means become same. So that is known as your equilibrium condition. Any doubt about this? And you can see from here, if your concentration of B and concentration of A becomes equal, it means K equilibrium will be 1 for this. So this is the condition where K is equal to 1. Any doubt? Please tell me. And take the screenshot of this. Okay. So now I'm going to talk about characteristics of equilibrium. At very first point, I already told you temperature, pressure, volume, and concentration remain same. And second point is rate of forward reaction is equal to the rate of backward reaction. This is a very important point. And third point is equilibrium constant only depend upon temperature, only depend on temperature. Means it cannot depend on concentration or other things. It depends only on temperature. Equilibrium constant means this K equilibrium. Okay. So this is the two characteristics point related to your equilibrium. Now, suppose you have a chemical reaction 2A plus B converted into 3C. So if you will write K equilibrium for this reaction, I already told you the concentration of product upon concentration of reactant. So suppose I am going to tell you about law of mass action. Law of mass action. Suppose you have a reaction 2A plus B which is going to C. You can apply your law of mass action for reversible and irreversible both. So suppose for this reaction, the rate directly proportional to the concentration of reactant molecule A and B. And this digit is known as stoichiometric coefficient. And it will raise to the power. So A power will be 2, B has just 1. If there is no value, it means 1. So B will be 1. So this is your law of mass action. Suppose I am saying 3A plus 2B, that will give you C. So for this, rate directly proportional to A to the power 3, B to the power 2. So this is the law of mass action. So if you will write the expression of K equilibrium for this one, so we can say this is time product is your C, reactant is your A and B. So we can say C power 3, A to the power 2, and B to the power 1. Or you can say 1 or nothing. So this is the expression of K equilibrium. Any doubt? Please tell me. Okay. Suppose we have a chemical reaction N2 plus 3H2 that is going to 2 ammonia. Sorry, ammonia only. So, no, here 2 ammonia. Yes. So now if I am going to write the expression of K equilibrium, so we can say concentration of product which is ammonia power 2 and then N2 and then H2 power 3. Okay. So this is about expression of K equilibrium. And if you want to write the unit of K equilibrium, then it is, for listen, K equilibrium is also categorized in two categories. One is Kc and one is Kp. Kc indicates in this way, means same. While Kp, we will write the expression in this way: capital P ammonia power 2, then capital P N2, and then capital P H2 power 3. Capital P means partial pressure. So this is only the difference. Partial pressure for any reaction. Any doubt? My request to everyone, if you have a doubt, let me know. Okay. So I am talking about unit of Kc, which is mole per liter delta Ng. And for Kp, it will be partial pressure we are using, so we can use ATM, atmospheric pressure delta Ng. What is delta Ng? Delta Ng means number of mole of product minus number of mole of reactant. So suppose we have a chemical reaction, the same one, suppose N2,3H2 ammonia. Now I am saying what should be the unit of Kc and Kp. So you can see mole per liter delta Ng, means what should be the delta Ng for this reaction. So I am saying number of mole of product. So you can see product is ammonia, which have 2 moles. So you can write 2 minus. Now the number of mole of reactant, and now you can see reactant have 3 here and 1 here. If there is no value, means 1. So that is equal to 4. So value will be minus 2. So we can say the unit of Kc mole per liter minus 2. This for Kc. And for Kp, it will be ATM to the power minus 2. Any doubt? And if your delta Ng is 0, it means your unit of Kc and Kp will be unitless, means there is no unit. We can take this one as example of it. Suppose you have H2 plus I2 2Hi. So if you are going to write delta Ng, you can see this is 2 minus this, both are 1 1, so 2, that is equal to 0. So Kc and Kp both are unitless. Now there is a relationship between Kp and Kc, which is Kp is equal to Kc RT power delta Ng. RT, R means gas constant and T is your temperature. For this one, delta Ng is supposed to be 0, it means Kp equal to Kc. If delta Ng greater than 0, it means Kp greater than Kc. If delta Ng less than 0, it means Kp less than Kc. So for this particular equation H2I2 2Hi, I am saying what should be the relationship between them. You can see my delta Ng is here 0. So we can say if it is 0, then Kp is equal to Kc. Okay. So tell me for this reaction, we have PCl5 break down into PCl3 and Cl2. Tell me what will be the relationship between Kp and Kc. Option number 1 equal to Kc. Option number 2 less than Kc. Option number 3 greater than Kc. Come on, fast. My request to everyone, please reply. Find first of all delta Ng. Then you can define your relationship. You can answer me on Messenger group, or you can answer me directly on Zoom chat. Okay, listen. Delta Ng, I said product minus reactant. Product has 2 mole minus reactant have just 1 mole. So 2 minus 1, which is 1. So delta Ng1, it means greater than 0. If delta Ng greater than 0, it means Kp greater than Kc. No, no, no. It will be product mole minus reactant mole. Okay. You can see this is my product and there is 2 mole, one Cl2 and one PCl3. So 2, then reactant is PCl5, which is 1. So 2 minus 1, which means 1. Any doubt? Please tell me. Okay. If you have a doubt, I can explain it again. So please tell me. Okay. So now you can see this is all about your Kp, Kc and expression. Now I'm going to discuss Lee-Chatterley principle. What is Lee-Chatterley principle? You know, if you will change the concentration, temperature, pressure and volume, your equilibrium will be disturbed. Okay, so that is what the Lee-Chatterley principle. Suppose you have a reaction A to B. If you will increase the concentration of A, then concentration of B will be go down, means it will decrease. So to maintain the equilibrium, if you want to maintain this reaction, to maintain the equilibrium or to maintain the equilibrium condition, the equilibrium will shift towards B because B has lower amount. So if you will move equilibrium towards B, then it will be balanced form. Makes sense? If you will change anything in any side, then that means the other side have lower or it can increase. So you have to balance this one. So we can move our equilibrium to that direction where we can balance that. So I'm going to talk about the very first effect, nature of, means we can say effect of concentration, effect of concentration of reactant and product. Means what will happen if you will change the concentration of reactant and product. Okay, so suppose we have a reaction A plus B into C. Now I am saying what will be the direction of equilibrium if we will increase the concentration of reactant. A is your reactant, A and B is your reactant, C is my product. So I am saying what will happen if concentration of reactant A will increase? What will be the direction of equilibrium? Equilibrium shift. In which direction? Tell me. Yes. Everyone is saying towards C. Towards C means forward. Yes, very good. Please say everyone, if you have a doubt, I will explain, but please reply. So listen me. I am saying if you will increase something towards the reactant side, it means the amount will be lower in product side, the other side. So if you want to balance this reaction, equilibrium will shift towards the lower side. So that means forward. So we can say it will be forward. Okay. Next question. What will happen if you will increase the concentration of product? What should be the direction of equilibrium? Tell me. Yes, right to left. You can say directly backward or forward, in this way. Yes, it will go backward. Why? Because I'm going to increase the concentration in product side. It means reactant has lower concentration now. So equilibrium will move in the backward direction to balance this. And the next is vice versa, means if you will increase A, forward, what will happen if you will decrease A? Then you can say backward. And what will happen if you will decrease the product concentration? Then we can say equilibrium shift forward. Any doubt? Please tell me. My request to everyone. Any doubt about this? Okay, no doubt, I think. So this is the change in concentration of reactant as well as product. I have a question for you. Suppose we have a chemical reaction H2 plus I2, which is going to HI. My question is, what will be the direction of equilibrium if we will decrease the concentration of HI? What will be the equilibrium, shifting means where it will shift? Tell me. Listen, HI is your product. So if you will decrease the concentration of product, it means product has lower mole. So equilibrium shift towards forward direction. So it will be forward. Okay. Now there is a note point. I want to tell you something important. So listen, you have two type of reactions. Suppose I am saying this is 2A, which is in gaseous form. This is 3B, which is in solid form. And this is equilibrium, which is 4C in gaseous form. We have another reaction. Suppose 2A gaseous plus 3B gaseous plus 4C gaseous form. So listen me. In above reaction, if everyone present in a same phase, and if every reactant and product is present in different phase, they have two type of nature. If they are in different phase, that is known as heterogeneous. And you can see above one is heterogeneous because it is a mixture of gas and solid, means we have few reactant and product in gaseous form and few are in solid form. If you have everyone in same phase, that is known as homogeneous. So this is my homogeneous. So listen me one more thing. Whenever you have a reactant or product in solid form, solid or pure liquid, the concentration will not be considered in expression. When you will write the equilibrium expression, there is no need to write the concentration of that one, means which one is present in solid or liquid. I can write here K, Kc suppose. Then you can see this is my product. So product is my C. The stoichiometry goes to the power. So power 4 divided by, and now you can see reactant is my A and B, but B is present in solid form. So we will not consider this one. So now you have only A. So A power 2. So this is my Kc. But for homogeneous, you can see this is, there is no solid form. So Kc is equal to concentration of C4, A 2 and B 3. Any doubt about this? Please tell me. So this is the nature of reaction, homogeneous and heterogeneous. Please tell me, please, please, please. Any doubt about this? Otherwise, I can move to the next slide. Yeah, you can take aqueous solution, not pure liquid. Okay, we have a question for you. Suppose we have a reaction CaCO3 solid form, CaO solid plus CO2 gas. My question is, if CaCO3 solid concentration is going to increase, then what will be the equilibrium direction, equilibrium shift in? Tell me. 1, 2, 3, or 4 option. Forward, backward, no change. You can say fourth means like none of this. Yeah, I got one answer. Someone is saying forward, someone is saying no change. Tell me, everyone. Yeah, someone is saying no effect. No change and no effect quite same in nature. Oh, none of these. Oh, sorry, I made mistake. None of these are different option. Okay, you can remove basically fourth one. You can remove fourth one. Now you have three choice. Forward, backward, no change. Means no change means no effect. Tell me, tell me, tell me. Yes, now I think you got the concept. No change. You know why? Because solid concentration is not be considered in equilibrium expression. So it's just CO2 gas only. Even not only this one, if you change this one as well, CaO, it will not influence the equilibrium direction. It will be the same, means no change, no effect of equilibrium. Any doubt? Please tell me. Tell me any doubt about this? Okay, perfect. So now the next one is effect of pressure and volume. Pressure and volume. So you can see both are pressure inversely proportional to volume. What does it mean? It means if you will increase your pressure, volume will decrease. Okay, tell me, if volume will decrease, what will happen? Number of mole increase or decrease? N means mole. Tell me. If your volume will decrease, then what will happen? Mole will increase or decrease? Tell me, tell me. I am saying volume will decrease. Mole will also decrease. Okay. So we can say on increasing pressure, equilibrium will shift in that direction where number of moles are less. Okay. Why? Because on increasing pressure, volume decrease and mole decrease. So if you will increase pressure, your equilibrium will shift in that direction where moles are less. So suppose PCl5 break down into PCl3 and Cl2. Got okay. You can compare your pressure reduce or increase, but first you should know what will happen if you will increase. Okay. So suppose I am saying if I will increase, now you can see product has 2 mole, reactant has 1 mole. So I am saying if you will increase your pressure, equilibrium shift in that direction where number of moles are less, and you can see reactant side has lower mole, so it will move in backward. So we can say pressure increase, equilibrium shift in backward. And one more thing I want to tell you, on increasing pressure, if it is backward, then you can write the effect of volume as well, because if you will increase pressure, your volume will decrease. So same effect means on in decreasing volume, your this reaction will move in the backward, means towards the less number of mole. So next is vice versa, means if you will decrease your pressure, equilibrium shift in forward. Because why? Because mole will increase. So pressure and volume both are inversely proportional. So if you will decrease pressure, volume increase. If you will increase volume, decrease. If you will increase pressure, decrease volume. Make sense? Please tell me. Please tell me about this one, the effect of pressure and volume. Simple, very simple. Okay, perfect, perfect. Okay, I have a question for you. This is a very famous reaction, N2 plus 3H2, it will give 2 ammonia. And now my question is, what will happen if you will increase pressure? And second thing, what will happen if you will increase volume? So you have to write equilibrium direction, equilibrium shift. So answer me for A, and this is the B, the next question. equilibrium shift? Tell me fast. So first answer me for A. Yeah, someone is saying it will go backward. Listen me again, I am saying the reaction will move towards that side where the number of moles are less. So first you have to find number of moles. So product here 2 mole. Reactant here 4 mole. So I am saying if you will increase your pressure, it means volume decrease. And if volume decrease, it means reaction will move towards lower volume, lower mole side. It means forward. So for this, it will be forward. And second factor, volume increase. Volume increase means pressure decrease. So on increasing pressure, if it is forward, it means by decreasing pressure, it will be backward. Please tell me about it. Any doubt? Please. Any doubt about this? Okay, perfect. Now tell me for this reaction. We have H2 plus I2, 2HI. We have this reaction and I'm saying what will happen if you will increase your pressure? What will be equilibrium? Shift. Tell me. I got one answer. Someone is saying nothing. Tell me. Yes, no change. You know why? Because product has 2 mole, reactant also have 2 mole. So if you have, both side have equal mole, it means equilibrium will never shift. No change, no effect on equilibrium. Make sense? Please tell me. Okay. Now the next is effect of temperature on equilibrium. This is very, very important one. Effect of temperature. So listen me first of all. According to the temperature, reaction is categorized in 2 categories. One is exothermic and second one is endothermic. Okay. So exo means heat will always be released. Heat release. Heat release means, and this is basically known as enthalpy, you can say. So heat release means delta H will be negative for this. And suppose you have any chemical reaction A plus B converting into C. So suppose if this reaction is exothermic, then heat will always be present towards product side. So you can write here heat. So whenever you have reaction in such a style, it means this is exothermic because we have a heat over product side. So what is endothermic? Endo means heat absorb. Heat absorb means delta H positive. If delta H positive, we can say the same reaction you can write in this way, A plus B, which is going to C. Now here we will write the heat towards reactant side. So this is the major difference between endothermic and exothermic. You can see for exothermic, heat will be in product side, and for endothermic, heat is present in reactant side. Now I can tell you the effect of temperature. So on increasing temperature, tell me where the temperature means where the heat is more present. Tell me, product side or reactant side for exothermic, where the amount of temperature is more, product side or reactant side? Tell me. You can just write P and R. I am saying again, yes, product. Any doubt about this? Because heat is present in product side, it means product has high temperature, means high heat. So tell me where the lower is heat, it means reactant side. So if you want to balance this equation, equilibrium will shift in the backward direction. Make sense? So we can say on increasing temperature, equilibrium shift backward. Why? Because heat is present lower in amount in reactant side, and if you want to balance this, equilibrium will shift in backward. So temperature decrease, that means forward. Simple. So we can say for exothermic reaction, on increasing temperature, reaction means equilibrium will move towards the backward direction. Now we can write for endothermic. So now you can see endothermic on increasing temperature. You can see heat is present in this time reactant side. It means product has lower heat, so equilibrium shift in forward. Shift in forward. Make sense? Please tell me. My request to everyone, make sense? You can see exothermic heat is present in product side. So if you will increase your temperature, equilibrium shift in backward. For endothermic, heat is present in reactant side. If you will increase your temperature, equilibrium will shift in forward. And in chemistry, heat increasing means heating effect, and temperature decrease means cooling. So sometimes they can replace the word like heating and cooling with increase or decrease. Okay. Please write this, take the screenshot of this. Yeah, I can move down. Like this. Okay, I just, this is better. Any doubt? Okay. Now the problem is how we can say any reaction exo and endo. This is the problem. Means how we will identify the given reaction is exothermic or endothermic. And there is one more thing I want to tell you, the graph of exo and endo. Listen, in exothermic, reactant heat is present high than product. This is reactant, this is product. This is potential energy, and this is progress of reaction. This is the graph. So this is one for exothermic. And this one for endothermic. Reactant has lower than product. So product have high energy, reactant has lower. You can memorize this one in this way. Whenever the graph is like that, something, this is exo. And when the graph is like this is endo. Simple. This is reactant, this is product, reactant, product. Okay, so my question is how we will identify exo and endo. So we can say all dissociation reaction. Dissociation means breaking. All dissociation reactions are endothermic. You know why? Because if you want to break something, you need heat or temperature, then you can break. Means absorbing here. Heat absorbs, heat will absorb. So that is known as endothermic. So all the dissociation reactions are endothermic like this. Suppose we have PCl5 break down into PCl3 and Cl2. So now you can see this is my dissociation reaction. And you can, it can be asked like this: what will happen if you will increase the temperature? What will be the direction of equilibrium? So you can see this is my dissociation reaction. So dissociation is endothermic. And if it is endothermic, it means heat is present in the reactant side. So if heat is present in the reactant side, then we can say equilibrium will shift in the forward. Simple. Okay. And now the association reaction. Association means formation. So association is exothermic. So we can take this one as examples. So more heat, more product endothermic. Yes, you can say. So association is my exothermic. Association means suppose you have N2 and 3H2, that will give you 2 ammonia. So now you can see this is, N2 and H2 that will combine to make ammonia, which means association, and association exothermic. So heat is present in the product side. So if you will increase your temperature, equilibrium shift backward. Make sense? Please tell me. Please. Any doubt? Please write down this one. So this is all about your equilibrium. I have discussed each and every important topic related to equilibrium. Now we can move to the question. Okay. Look at this question. Question 49. Just give me a second. So now you can see okay, now you can see 49 question. So here calculate the lead concentration of a patient blood if the concentration of PbEDTA twice minus 2 charge, that is equal to 2.4 into 10 to the power minus 2 molar. So this is the concentration of PbEDTA, okay, which is 2.4. And now we have another concentration EDTA minus 4 is equal to 1.2 into 10 to the power minus 4 molar. And it is asking about lead concentration, means Pb plus 2 concentration. We have to find this concentration. So if you look at this K equilibrium expression, can you see this? This is the expression I'm talking about, K equilibrium. You can see that is equal to Pb plus 2, EDTA minus 2, minus 4, sorry, divide by Pb, EDTA twice. 2 charge, sorry, not twice, minus 2 charge. So you have the equilibrium value here. You can read the very last line of information. You can see at normal body temperature, the equilibrium constant for this reaction is 6 into 10 to the power minus 19. Means we have the value of K equilibrium, which is 6 into 10 to the power minus 19, which is equal to, we have to find this left, so we can assume this one as X. And EDTA minus 4 charge, which is given 1.2 into 10 to the power minus 4, divide by this concentration is given, which is what? 0.4 into 10 to the power minus 2. So this minus 2 and this minus 2 you can cancel out, and you can see 6 into 10 to the power minus 19 is equal to x into 1.2 into 10 to the power minus 2 divided by 2.4. Make sense? And you can see if you divide this 1.2 to 2.4, that is 2. And this 2 can be multiplied this 6. So that will be 12 into 10 to the power minus 14. And which is equal to x into 10 to the power minus 2. Makes sense? Answer should be, I think, what? Tell me. What should be the answer? I think it should be 12 into 10 to the power 17, something like. Tell me the answer. What should be? It's very close one. So your mathematics should be strong. But the method of, solution should be like this. You can solve in this way. Tell me any doubt about this, please. You can find your answer. I don't think that it can create any problem to you. It's very easy one. You have to just put the value and solve. Any doubt, please tell me. Oh, sorry, I made mistake. This is 19, not 14. This is 19 because this is 19. Okay, so this will be 19. So you can see if you will cut down, this will be 12 into 10 to the power minus 17, which equal to x. So this is 12 into 10 to the power minus 17, but your options is 1.2. So if you will write this one 1.2 in terms of 1.2, that will be 1.2 into 10 power minus 16. So I think it should be A. I'm not sure about the calculation. You can cross check. Can you see the solution? Any doubt, please tell me. Okay, now you can try question number 50. Yeah, this is the first half of the solution. Entire solution is this one. This is my answer. 1.2 into 6, 10 to the power minus 16. Okay. Perfect. Now tell me about question number 50. Tell me. What should be in term 50? The rate of dissociation of certain chemical into ion in a solution is favorably increased by presence of catalyst. Now listen the line carefully. It is saying catalyst increases rate of reaction. Rate of reaction. This is the, the main line. Which of the following is not true? We have to find not true statement. So we are in equilibrium chapter, and I discussed the point of equilibrium with you, that this is basically related to catalyst. I told you that catalyst will not affect equilibrium. It can only affect rate of reaction. Rate of reaction. So if you have any option where does not change, that will be the right choice. So now you can see. Does not change the value of equilibrium constant at 25 degrees centigrade. Absolutely fine, because catalyst will not influence equilibrium constant. So this is the fine statement. So this is not true, which is not, this is a true statement. Now second point, increase the rate of precipitation of a chemical form it ions. So increase the rate of precipitation, it means it is talking about increase the rate of reaction. Okay, so second statement is also true. Now the third one, lowers the activation energy by enabling solution via an alternative path. So basically, this is the concept of activation energy and rate of reaction, which I will discuss in kinetics. Okay, because activation is related to kinetics, but I can tell you something. Listen me. Catalyst increase the rate of reaction. Rate of reaction increase by decreasing the activation energy. Okay, so this is the important line. Rate of reaction increase, but activation energy will decrease. So what should be the C is also true, because if you will lower the activation energy, it means rate of reaction will increase. So now move to D. Increase the equilibrium concentration of the ions from the chemical in solution. So D is wrong statement, because catalyst will not change equilibrium concentration. Yes, D is the answer, which is not true. Any doubt about this question? Please tell me. Please, please, please. Any doubt about this? Okay, now we can move to another question. So read this question carefully and tell me what should be the option answer for this. This is the question 69. And this is the information in the question. We have an expression of K equilibrium in which ethyl bromide and we have two concentration of product upon concentration of reactant. Tell me what should be the answer for this. 69. The question is here, if more hydrogen bromide is added to a reaction mixture, what equilibrium has been established? The equilibrium constant will be. This is your K equilibrium expression. So listen me, I am saying we have K equilibrium, which is equal to concentration of ethyl bromide, C2H5Br suppose, divide by concentration of alkene, means CH2 double bond CH2, and another HBr. This is K equilibrium expression. Now the question is here, if more hydrogen bromide is added, and this is basically the reaction, means CH2 double bond CH2 plus HBr, that will give to the C2H5Br. Okay, so now you can see this is my reactant, this is my reactant, and this is a reactant as well, and this is a product. So it is very clear, if more hydrogen bromide is added, it means we are increasing the concentration of reactant. We are increasing the concentration of reactant. So equilibrium should shift in forward. We studied in Le principle, but I am again saying equilibrium, not equilibrium constant, because I already told you equilibrium constant only depend upon temperature, only depend on temperature. So it does not change by change of any concentration of reactant or product. So tell me which of the following answer is fine. And I can tell you the value of equilibrium, that is 7.5 into 10 power 7, which is given 7.5 into 10 to the power 7. It is given in the question, K equilibrium value. And now the question 69, what should be the value? More than this, less than this, or equal? Tell me. This is K equilibrium value, you can see 7.5. Yes, very good. It will remain same. Why? Because K equilibrium will not change by change in concentration of reactant or product. It can only be changed with the change in temperature. Make sense? Please tell me. Yeah, so answer should be equal to 7.5 into 10 to the power 7, which means what? B. B will be the right choice. Any doubt? Please tell me any doubt about this question. Okay, now we can move to the next. So here, a very famous question based on completely Lee-Chatterley principle. Tell me, what should be the answer for this? Question 45. We have a reaction. We have a reaction which is formation of ammonia. You can see you have a reaction N2 plus 3H2. That will give 2 ammonia. Now 45, what will happen? There is two factor, you know. The very first factor, what will happen if you will increase your pressure? Then increase pressure, what will the effect over rate of reaction? It will increase or decrease? This is the first question. And second is, what should be the nature of reaction? Endo or exo? Endo or exo? So tell me first, nature of reaction this. Exothermic or endothermic? Tell me. N2 plus 3H2, 2 ammonia. What is this? Endothermic or exothermic? Okay, tell me, association or dissociation? Association or dissociation? First tell me, association or dissociation? Yes, association, association. Please say everyone, association. Why association? Because N2 and H2 combine to form ammonia. It can be dissociation if the reaction in this manner. NH3 break down into N2 and plus 3H2. You can see this is your dissociation. Why? Because this is the breaking of ammonia which can produce N2 and 3H2. But the top reaction, which is the given reaction, that is your association reaction. Okay. Make sense about association? If it is association, then tell me what will happen. Exo or endo? Yes, very good. Exo, 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 exo. So A and B is completely wrong. Now we have C and D. Okay, so we are done with exothermic. Now the second question. Tell me what will happen if you will increase the pressure. Collision will be more or less. Suppose I am saying you have a beaker where 2-3 balls are there. I am saying what will happen if you will increase pressure. Collision will be there or no? No collision. Tell me. If you will decrease the pressure, if you will increase the pressure, it means the collision will be high between them. They will collide. Collision increase. So we can say number of collision increase. And if number of collision increase, then we can say rate of reaction will increase. Okay. So effect of increase in pressure as well as increase in temperature, both have same effect, means both will increase the rate of reaction. So for this 115 unit, Desonil chapter 9, page 201, the question 45, option number D. Why? Because this is the formation of ammonia, which is association reaction. So that's why this is exothermic. And if this is exothermic, and the second question, pressure increase, then we can say rate of reaction will increase. Any doubt about this one? Please tell me. Any doubt about 45? Okay. What about 46? What about 46? 46. The question is here, which one is the best method for the formation of ammonia? Means best condition for formation of ammonia. So formation of ammonia, if you look at this reaction N2 plus 3H2, which is good to ammonia, I am saying which one is the best method for the formation of ammonia? It means ammonia should be more, means the ammonia should form more in amount. That the mean of this. So it means rate of reaction should be better. Rate of reaction should be high. And rate of reaction should be high means it can be happen if you have high temperature and high pressure. Means if you have high temperature and high pressure, it means it will increase the rate of reaction. And if it will increase the rate of reaction, it means formation of ammonia will be higher in amount. And there is only one option in which pressure and temperature both are high. So you can eliminate all of them. Any doubt about this question? And if you have a doubt about removal of ammonia, hydrogen only, ammonia only, nitrogen only, I can discuss this one as well. So listen me. So let's go with ammonia, removal of ammonia only. So removal of ammonia means we are decreasing the product concentration. Product concentration. What does it mean? It means equilibrium shift in forward. And if equilibrium shift in forward, it means more ammonia will form. So removal of ammonia only will be the right choice. You cannot remove hydrogen and nitrogen because this is reactant. If you want to move forward, you will have to increase this, not eliminate this. Make sense? Please tell me. In Lee-Chiterley principle, please focus about the concentration change. So if you will increase the reactant concentration, then equilibrium will shift in forward. And if you will decrease the product, then again it will be forward. Any doubt? Please tell me. If this reaction is exothermic, should not we have low temperature? Listen, if you want to discuss about the exothermic, then you will have to write the reaction in this way. Means ammonia move into N2 plus 3H2. So in that case, you have to increase the concentration of ammonia, not to remove this. You have to add this addition. Then it can be better for forward reaction. And this is your exothermic. So you cannot say like this is the formation of ammonia, the top reaction, and you are assuming this one as exothermic. No, this is endothermic because this is the association. Sorry, I made mistake, I think. Association is exothermic. So this reaction is exothermic. If this reaction is exothermic, it means if you will increase your temperature, the reaction will proceed towards the more forward direction because rate of reaction will increase. No, you cannot listen. Low temperature, you know what I discussed? I told you that the effect of temperature with equilibrium, not the rate of reaction. Here the question is what will be best condition for the production of ammonia? So high temperature will be the best condition for a high rate of reaction. It makes sense? Okay, perfect. So this is all about your equilibrium. Now we can move to the next, which is your kinetics. So kinetics, chemical kinetics, we can say. So chemical kinetics means it is a branch we can study about rate of reaction and factor affecting the rate of reaction. Okay. So for this chemical kinetics, what is rate? Rate is basically change in concentration upon change in time. Delta C means change in concentration, and delta T means change in time. Okay, this is the rate. And now we can move to the rate law. Suppose we have a chemical reaction A plus B, which is going to C. And what is rate law? Rate law is the rate depends on the concentration of reactant. This is the rate law. Okay. And if you will eliminate the constant, you can write K, A and B. K is your rate constant. So this is the rate law. According to the rate law, rate of reaction directly proportional to the concentration of reactant molecule. Okay. So this is about rate law. Now, reaction is basically two type. The first one, we can say elementary or simple reaction. And second one is complex reaction. Suppose we have A plus B going to C. So we can define for rate this reaction rate directly proportional to concentration of A, concentration of B. Okay. So rate is equal to K, A and B like this. Suppose here 2A, then stoichiometry like this. Okay. And B is 1, so you can write 1. Now what will in complex reaction? So complex, suppose same reaction 2A plus B, which is going to C. If you will apply rate law here, then rate directly proportional to concentration of A, concentration of B. But this stoichiometry will not be to the power of A and B for complex reaction. It can be any number, suppose X and Y. And this X and Y comes from experiments. So we can say X and Y is experimental value. And we can tell you about this. So for elementary reaction, what does mean like A to the power 2? We can say second order reaction with respect to A. And if you look at B, we can say first order reaction with respect to B. And if I am saying suppose overall reaction, then overall will be 1 plus 2, which means 3. So third order kinetic overall for elementary. Tell me about this one. I am saying 2A plus A plus 2B. Wait. A plus 2B, that will give C. I am saying suppose this is my elementary reaction. Tell me order of reaction with respect to A and order of reaction with respect to B. Tell me. I am saying this is elementary. First order with respect to A and second order with respect to B. Very good. Very good. Very good. First order with respect to A. Because if you will write the rate law for this reaction, that is directly proportional to A and B to the power 2. So B to the power 2 means second order for B, first order for A, overall third order. Overall. Okay. If you want to write the screenshot, you can. Please write down. Suppose we have a complex reaction this time. I am saying 2a plus b, that is going to c, and I have given you the rate law for this. For complex reaction, it will inform you this is complex, so don't worry about it. And rate law also mentioned in the question. Rate law directly, sorry, we can say rate directly proportional to a and b to the power 2. Suppose this is in the rate law. Now tell me what will be the order of reaction with respect to a, and what is the order of reaction with respect to b. So for complex reaction, you can find your order of reaction if you have a rate law. Now it is very easy. You can see A has just one power, so we can say first order kinetic. B has two, so we can say second order kinetic. Any doubt, please tell me. Please tell me. Okay, perfect. Okay, now one more thing I want to tell you. Suppose you have a reaction A plus B equal to C. So in any chemical reaction, this is your reactant and it will always be disappear. Disappear. And they have negative sign. This is your product, it will always appear, and that will be positive sign. So for this type of reaction, we can say rate of disappearance of reactant always equal to rate of appearance of product. Okay, so we can write in this way. This is A, so we will write minus because this is reactant, minus. And now you can see change in concentration upon change in time. So we can say minus D concentration of it divided by dt. What is dA? What is D and dt? Listen, D indicates for small change. So dt means change in time and dA means change in concentration of it. So we can say dA by dt. And that is equal to, this is B also reactant. So we can say minus dB by dt. And now it is equal to, this is C, which is a product and it will appear, so positive sign, and we can say dC by dt. Okay, so what does it mean? It means this is A, we can say this is a rate of disappearance of A, rate of disappearance of A. This is rate of disappearance of B, and this is the rate of appearance of C, rate of appearance of C. Any doubt, please tell me. Please tell me, everyone. Any doubt about this expression? Please note this. Now what will happen if you have this expression? 2a plus 3b, that will give 4c. So listen this time. If you have stoichiometric values, you can write this one as reciprocal, means like this. Suppose this is 2. So we will say minus 1 by 2. Now the same thing, dA by dt. That is equal to minus 1 by 3. dB by dt. And that is equal to 4. So plus 1 by 4 dC by dt. So this is the formation of C, means appearance of C. This is disappearance of B, disappearance, and this is disappearance of A. Suppose we have this reaction N2 plus 3H2, that will give you 2 ammonia. So how can you write this one? So we can say minus dN2 divided by dt, which is equal to minus 1 by 3 dH2 divided by dt, and that is equal to plus 1 by 2 d ammonia by dt. Any doubt about this expression? Please tell me. My request to everyone. Any doubt about this expression? Okay, very good. Suppose a very famous reaction we have. And one more thing I want to tell you. Suppose you have A plus H2O, that will give B. So if you will apply rate law, directly proportional to only A, not H2O, because H2O amount is liquid, which is excess. So we cannot write in rate law the concentration of H2O. So it will always be A. Okay. So it means rate depend on only concentration of reactant A, not H2O. So any doubt about this condition, please tell me. Okay. Suppose we have this reaction, sucrose, a very famous reaction, sucrose plus H2O. That will give glucose and fructose. Sucrose means C12H22O11. So this reaction is carried out in presence of any acidic medium. Suppose you have H plus. So now you can see this is H2O, which is present in reactant. So this concentration, there is no mean of that. So if you will write the rate directly proportional to concentration of C12H22O11. And this H plus you can take because medium is acidic, so H plus, not H2O. Okay, so rate depends upon concentration of sucrose as well as hydrogen ion concentration. Any doubt, please tell me. My request to everyone, any doubt? Yes, please listen. Listen me again. I am saying if any reactant side have H2O, then the concentration of H2O is not important. Since this reaction is carried out in the presence of acidic medium, this H plus, it can come from any part like HCl. You can see we have suppose acid HCl, so H plus donor this is. So this reaction is carried out in the presence of H plus. So we can say the H plus is important here. So we can take H plus with sucrose, not this H2O, because H2O also can donate H plus and OH minus. But the concentration of H2O, whenever it is present with reactant, it will never be, important. Makes sense? So this H plus comes from HCl, not H2O. That is what I am saying. Listen, I am saying this reaction will be given in your question. I am saying this will be given in your question. It will never be say like H plus you have to memorize this reaction. No, it will be given. So what you have to do. Okay, now I am creating a question with this reaction. So listen me carefully. I am saying rate of appearance of glucose. I am saying rate of appearance of glucose, true and false. Okay. So tell me, I am saying rate of appearance of glucose is equal to rate of disappearance of sucrose with the same sign. With the same sign. Tell me, is this true or false? Look at the reaction carefully. This is sucrose, this is glucose. I am saying rate of appearance of glucose is equal to the rate of appearance of disappearance of sucrose with same sign. True or false? Yes, this is not true. Why? You can see this is glucose, which is product. And you can see this is sucrose, which is reactant. and I am going to correlate both of them. Sucrose with glucose, sucrose with glucose, and you can see product will always be appear. Okay, so glucose will appear, that is fine. Sucrose will disappear, that is fine, but they should have opposite sign. So not say, if it is opposite sign, then we can say it is true. Make sense? Please tell me. So they can form such a type of question in your exam. Please tell me, any doubt about this? Okay. I can discuss a question, same question with you. Just give me a second. Yes, we have this one. Yes, finally I got it. So you can see the same question. We have, look at the question number 56. Don't think about any other question. Just tell me about 56. 56. Now you can see, I can read the line. As the hydrolysis of sucrose progress, this is your reaction C6H12O6 O11 C2, sorry, C12H22O11. When it will proceed plus H2O, that will give C6H12O6 plus C6H12O6. So now listen me, I am saying as hydrolysis of sucrose progress, the rate of change of concentration of glucose will be equal to. This is your glucose. The rate of change of glucose is equal to the sucrose. What should be answer? Tell me. You know, you can eliminate half of the rate very clearly. You know why? Half of the the term half of the rate is only applicable if they have some stoichiometry value. Suppose I can say here 2 mole of sucrose, then you can write -1/2 d sucrose divided by dt. Then you can say this is half of the rate. If there is no 2, you can see in main equation there is no stoichiometry. So the word 2 or half or 2 time 3 time, it will never be in this line. Any doubt? So C and D is completely wrong. Please tell me, any doubt about C and D option? So tell me which of the final answer. The rate of change of sucrose concentration have the same sign with glucose? Absolutely not, because same sign is only be possible if they both are in same side. So they both are in different side, it should be opposite, and opposite is only present in B and C. But again, D is half of the rate, so D you can eliminate D very easily. So there is one option which is B. So this is the best thing about GAMSAT. If you have a basic idea about your concept, then you can eliminate at least 2 options very easily. 2 options, minimum 2 options you can eliminate very easily, even 3. And suppose there is 4 options, 1, 2, 3, 4. Just listen me. 1, 2, 3, 4. If you have, I am saying with application of basic concept, only basic concept, you can remove 2 options very easily. Suppose 3 and 4 is not, now you have 1 and 2. So out of them you can find your correct answer very easily, because only one will be very close to the real answer. Second will not be the real answer. Only one. So you can eliminate C and D very easily. So C and D is not there. And now again, I am saying the basic concept. You can see glucose and sucrose both have opposite directions. So they should have opposite sign. And now you can see the combinations. Opposite sign is only present between B and D. And I'm saying D is not possible. So only B is the right choice. Makes sense what I'm saying? Please tell me. Okay, perfect. Now we can move to next. Okay. Now I'm going to find out the table for the order of kinetic. Listen, one more thing. If you have any reaction A to B, that will give you C. Suppose A, B plus C. That's okay. So you can write rate for this. Rate directly proportional to concentration of A. And rate is equal to Ka as well. Okay. So now I'm going to talk about unit of K, unit of rate constant. This is very, very important. So it is mole 1 minus n liter n minus 1 second inverse. This is unit. What is n? N will be order of reaction. So if you have n is equal to 0, then your unit will be what? Mole 1 liter minus 1 second minus 1. And if you have n is equal to 1, then the unit will always be second minus 1. And if you have n is equal to 2, then unit will be mole minus 1 liter 1 second minus 1. Any doubt about unit, please tell me. You can put those values and find your answer. Please tell me. Any doubt about this? It makes sense? Oh, you don't get it. Listen, I am saying, suppose the very first condition 1, where n is equal to 0. So put n is equal to 0 over here. So mole 1 minus 0, liter 0 minus 1, second minus 1. So if you solve this one, mole 1 minus 0 means mole 1. Liter 0 minus 1 means liter minus 1. And this is second inverse. Make sense? So we can say n is equal to 0 means I am talking about 0 order kinetic. This is 0 order kinetic. First means first order kinetic. Second means second order kinetic. So they can directly ask what should be the unit of rate constant K for second order or first order or 0 order kinetic. Any doubt? Okay, this one is for you. What is the unit of K? Unit of K for third order kinetic, and only you have to tell me about liter, the volume one, not only mole and second. Just tell me about liter, what it should be for third order kinetic. Yes, it should be 2. Yes, very good. It should be 2. Any doubt? Because you can see it is a n minus 1. So if you will put n is equal to 3, 3 means third order kinetic. So when you will subtract, then you will get 2. So liter must be 2. Make sense? Please tell me. Any doubt about this? Do you include mole in it then? No, no, no. There is no need of mole. N means order of reaction. N means order of reaction. And order of reaction, I will tell you how to find. So this type of table is very important. Listen me. One more thing I want to tell you. You have suppose one thing you should know, rate only depend on concentration of reactant. Okay. So I am just writing here concentration of reactant, rate, and order of reaction. Order of reaction. Look at this table carefully. I am saying I am going to change my reactant concentration 2 times. 2 times. Suppose at that time my rate is same, means constant. There is no change in the rate. Then that order of reaction will be n, that will be 0, means 0 order reaction. Means the concentration of change in reactant, if your rate is same, means there is no change, then we can say that will be 0 order kinetic. And suppose if you are going to again change 2 times your concentration of reactant and rate becomes 2 times, then we can say it will be first order kinetic, means n is equal to 1. So when the change is happening in the same ratio, suppose I am saying my rate of change in concentration 3 times and rate also becomes 3 times, then order of kinetic will be first order. So same ratio will always indicate first order kinetic. Make sense? Please tell me. Okay, suppose I am saying again I am going to change it 2 times and my rate become 4 times. Now tell me what is this? It will be second order kinetic. Very good. Suppose again 2 times and this become 8 times. Tell me what should be? Yes, perfect. Now listen me again. What will happen if you will change the concentration of reactant 3 times, 3 times, and rate become 9 times? Tell me, what should be order of kinetic? Tell me, everyone. Yes, second order kinetic. Second order kinetic. Yes. Now you can write this is, you can save this one. Take the screenshot of this. Please take the screenshot. Okay. Now we can move to the question. Determination of rate law and order experimentally. This is a very important concept. Suppose they will give you a table experiment. Here concentration of A, here concentration of B, and here you have a rate. Suppose we have 3 experiment 1, 2, and 3. The concentration of reactant suppose 0.1, 0.2, 0.2, 0.2, 0.2, 0.4. And this value suppose you have 2 into 10 to the power minus 2, 8 into 10 to the power minus 2, and 16 into 10 to the power minus 2. It will always given in your question, A plus B convert into product. And they will give you this one as well, rate directly proportional to concentration of A power B. This is X and this is Y. Now they can ask what will be the value of X and Y. So how can you solve this one? Listen me very carefully. Suppose I have to find X. I am saying we have to find X. So X means I am talking about A. So if you are talking about A, then keep B constant. Just listen me. I am saying if you are talking about A, then keep B constant. And if you look at B, B is constant here. Constant. And now you have to compare your rate of change with change in concentration. So you can see if you look at these two data, 1 and 2, the concentration of reactant becomes 2 times. 0.1 to 0.2, it means 2 times. And your rate becomes 4 times. You can see 2 to 8. What is 3? 4 times. So tell me what should be the order of kinetic with respect to A? Means what is the value of X? I am saying concentration change 2 times and rate becomes 4 times. Then what should be? Second order kinetic. Listen me again. If you will change 2 time, rate has no change, then 0 order. If changing 2 time, rate becomes 2 times, then first order. If change in 2 time, rate becomes 8 times, then we can say third order. Okay, like this. So this is 2 time and this is 4 times. 2 4 ja 8. Okay, so this is 8. So we can say this is 4 time and this is 2. So we can say second order kinetic, means X will be 2. So we can say here X will be 2. Now we can check Y. So if you are going to talk about B, then you will have to keep A constant. A constant. So A constant is present in this data. And now compare the rate of change. Now you can see 0.2 to 0.4, which means 2 time. And 8 to 16, that is also 2 times. Now tell me what should be the order of kinetic? Yes, first order. So X is equal to 2, Y is equal to 1. So we can say A to the power 2, B to the power 1. That is rate is equal to K. And it's overall third order kinetic. Overall third order. Any doubt, please tell me. Again, listen me. If you are going to check your A, keep B constant. If you are going to check B, then keep A constant. Simple. Please tell me any doubt. Okay, take the screenshot and I can give you another question. Suppose we have this one. A, B rate. This is experiment. 1, 2, and 3. I'm saying this is 0.50, 0.51. This is 0.50. This is 1. And this is 1. This is 1.6 into 10 to the power minus 4. This is 3.2 into 10 to the power minus 4. And this is 6.4 into 10 to the power minus 4. Tell me about rate directly proportional to A to the power X, B to the power Y. Find the value of X and Y. Tell me. So many questions in your Dezonil and SR set about this. And this is pretty easy one. If you are talking about A, keep B constant and then compare the change in concentration with change in time. Someone is saying both is second order, second order. Listen, if change in same ratio, that is not never be your second order. Same ratio means first order. Listen me. Suppose I am talking about A. Now keep B constant. Tell me where the B is constant. This is constant. Compare the rate with change in concentration. You can see 0.5 to 1, which means 2 time. And look at the rate 3.2 to 6.4. You can write like this 32 and 64. Now you can see 2 times. So now you can see both in same ratio. And I told you that if it is in same ratio, then we can say first order kinetic. So X will be 1. Now move to B. Keep A constant. This is constant. Compare the B with rate. B 2 times rate becomes 2 times, then 1 again. So a to the power 1, b to the power 1, that means first order with respect to both, and overall second order kinetic. Any doubt, please tell me. Please tell me any doubt about this question. Okay, perfect. Now I have a question for you. Just give me a second. Okay, can you see question number 77? Tell me what it should be. Just tell me the answer. Which option is fine? A, B, C, D. Someone is saying D, someone is saying C. Listen me again, I am saying if your concentration become 2 time, rate becomes 2 time, then first order. If concentration become 2 time, rate become 4 time, then second order. If concentration become 2 time, rate become 8 time, then third order. So suppose I am talking about X, then you have to keep Y constant. Y is constant between 2 and 3 experiment, means the value is 0.2 and 0.2. This is constant. And X becomes 0.1 to 0.2, 0.1 to 0.2, which means 2 time. And at that time, if you look at the rate, that is 0.4 and that is 1.6. You can, if you have a problem with decimal, you can write down this one as well. After decimal, there is 1 digit, and after decimal, there is 1 digit. So 4 and 16. Now you can see 4, 4 just 16. So 4 times. This is 2 time, this is 4 time. So this is second order with respect to X. Please tell me, any doubt about X? Please tell me any doubt. And now you can see if X has 2, then it can be A, it can be D. Now tell me what is happening between A and D. What should be the right choice, A or D? Of course, D. Yes, because Y first order kinetic. Y first order. I can check as well. Listen. If you are going to find Y, keep X constant. X is constant between 1 and 2 experiment, means 0.1 and 0.1, which is constant. And if you look at Y, this has become 0.1 to 0.2, which means 2 time. And at that time, rate becomes 0.2 to 0.4, which means 2 time. So you can see same ratio of change, 2 time, 2 time. It means it is first order kinetic. So Y power will be 1. Any doubt? If there is no power, it means 1. So D, Y has 1. So Y means D will be the right choice. Any doubt, please tell me. It makes sense. I can find some more question. Yes, here we have. Okay, tell me about this one. Question 2. Question 2, can you see? Please tell me which of the following answer will is find in question 2. The rate equation for the reaction can be written rate is equal to KH2O1. Then it is talking about H plus zero order kinetic. Listen, if it is talking about, if there is three table in here, we have three table, you can see. You can see here we have three table, H2O2, H iodine minus and H plus. And you can see if H plus has zero order kinetic, it means it does not depend on the rate law, means that has zero. So you cannot write in, suppose rate directly proportional to H2O iodine minus, and if there is no H plus in the rate law, it means it is zero order kinetic. So tell me which one should be the fine. Okay, let's check out the very first option. The rate equation for the reaction can be written KH2O2 iodine negative. What does it mean? It means both is first order kinetic. From this equation, means from statement 1, it is talking about H2O2 is first order as well as iodine first order. Now we can find H2O2. So if you look at H2O2, keep iodine constant as well as hydrogen, both. So if you look at experiment 1 and 2, if you look at experiment 1 and 2, so H2O2 becomes 0.01 to 0.03, 3 times. And at that time, rate becomes 2.026, means 2 to 6, means 3 times. I'm saying whenever the change in same ratio, it will always be first order. So we can say H2O2 is a first order kinetic. Okay, which is fine with H2O2. Now we can check iodine negative. So in iodine negative, keep H2O2 constant as well as hydrogen. So H2O2 is constant. Yes, we have the value. It is going to 0.01 to 0.02, the iodine minus 1, and H2O2 is constant, and the rate is 6.0 to 1.2, 0.03 and 0.03, which is constant. So this becomes 2 times. And this is also become 2 times. Oh yes, this is also 2 times. I can tell you why. You can see the above data. This is 6.0 into 10 to the power minus 6, and this is 1.2 into 10 to the power minus 5. So you can write this one as well, 12 into 10 to the power minus 6. So now you can see minus 6 is common, and this is 6 to 12, which is 2 times. So this is 2 times, this is 2 times. Iodine is also first order kinetic. Okay, now you can take H plus. So keep H2O2 and iodine both constant. Yes, we have the value in which they both are constant. Just look at the very last 2 experiment value. Iodine is 0.02, 0.02 in that case, and this is 0.03, this is 0.03, which is constant. Both are constant, means your H2O2 as well as iodine negative constant. And H plus concentration is what at that time? 0.1 to 0.2. And rate is 1.2 to 10 to the power minus 5 and 1.2 to 10 to the power minus 5. Now you can see 0.1 to 0.2, which means 2 time. And this is same 1.2 to 1.2 cm means no change. And I told you that if you have no change, it means order of reaction will be 0. So H plus concentration power will be 0. So option 1 is absolutely fine. H2O2 first order, iodine first order. Very good, no doubt. Now the second, the reaction is 0 order with respect to H plus. This is also absolutely fine. There is no doubt. Because 0 order, 0, then that's why H plus is not in the rate law. Now the third is the rate constant is 2.0 into 10 to the power minus 1 mole minus 2 liter to S minus 2. Mole, sorry, the value is 2.0 into 10 to the power minus 1 mole minus 2 liter to second minus 1. Tell me without calculation why 3 is wrong. 3 is wrong. There is no need to calculate this. I can tell you. Listen me. I told you the unit of K, rate constant unit. This formula, mole 1 minus n, liter n minus 1, second inverse. And you can see this is minus 2 and liter 2. Liter 2 is only possible if your order of reaction is third order, n is equal to 3. But from the equation, H2O2 has 1 and iodine minus has 1. So overall the reaction is second order kinetic, but your unit becomes third order kinetic. It never be possible. That's why 3 is wrong. Any doubt, please tell me. It makes sense about the last statement, the rate constant one. Why this is not possible? Because the unit is third order kinetic unit, which is not possible. Yeah, it should be second order unit. It should be second order, which is mole minus 1, liter 1, and second minus 1. Yes, absolutely perfect. So third is wrong. Now we have 1 and 2. So option A is a fine. Any doubt, please tell me. How do you find? Listen, in overall kinetic, you have to just add both powers. Both reactant power value, you just have to add them. You can see both had 1, 1, so it will be 2. Any doubt, please tell me. Now we can solve the question number 1 as well, which is a very good question. Listen me, I can tell you one thing. Suppose you have any reaction A plus B, that is going to C. And it is saying this is complex reaction. So complex reaction always have steps. Always have steps. Steps means saying first step, second step, like that. So this will be mechanism here. Suppose mechanism is A to C and mechanism is here, suppose B to C, like this. This is supposed to be slow step. This is supposed to be fast step. Then listen, I'm just talking about a hypothetical example. I'm not saying this is the correct or not. I'm just talking about a hypothetical. Suppose this is a chemical reaction and these are the steps 1 and step 2. So I am saying the step 1 is slow step and second step is fast step. So slow step is always a rate determining step. Slow step always rate determining step, RDS. Means when you will write your rate law, you have to always focus about slow step, and you know rate directly proportional to the concentration of A only. Because this is your slow step and here this is the reactant and that depends on A. Any doubt, please tell me. Why? Because slow step is rate determining step. So in rate law, the slow step reactant will be there. Please tell me. Any doubt? And now tell me about this question. Yeah, question number 1. Sorry. What will be question number 1 here? Answer. We have a complex reaction and then we have some mechanism in slow step and fast step. Tell me what it should be. Someone is saying D. I think, Rohina, you are absolutely right. Why? Because if you look at slow step, I can write here RBR, that is going to R plus BR negative, and then R plus OH negative, that is ROH, and then there is a rate. So if you look at, this is the slow step, the top step is your slow step, and the down one is your fast step. And I told you that rate determining step is slow steps. So this step is only important here. And if you are going to write the rate for this reaction, then you can see for the rate directly proportional to the concentration of RBR, because this is your reactant RBR. So rate is equal to K RBR. Any doubt? Please tell me. So answer should be D. Please tell me any doubt about this. It makes sense? Okay, perfect. Now I'm going to talk about the effect of catalyst for the reaction. Listen, I told you that in equilibrium as well, catalyst will always increase the rate of reaction. Catalyst always increase the rate of reaction if you have positive catalyst. Then if you have negative catalyst, then rate of reaction will decrease. And if rate of reaction increase, activation energy decrease. And if rate of reaction decrease, activation energy increase. What is activation energy? I can tell you. Suppose we have a graph like this. This is reactant, this is product. This is potential energy and this is progress of reaction. Now tell me, what is this, exothermic or endothermic? I discussed in equilibrium. What is this graph? Exo or endo? Please tell me. This is exo. Okay. So listen me. This is reactant and this top peak position is known as transition state. And this gap from reactant to transition state, this energy gap is known as activation energy. Okay, write down. This energy gap is your activation energy. And the gap between energy of product and reactant, this energy gap, that is known as delta H. Make sense? Please tell me. Any doubt? Any doubt about this, the activation energy concept? Yeah, blue is your enthalpy, that is delta H. Enthalpy means heat of the reaction. Okay. Now this one is very important concept. Listen me. Suppose any graph is like that. Oh, I missed one thing. That the catalyst role with activation energy. Listen me. Suppose this is a chemical reaction. This is my natural activation energy without catalyst. This is the activation energy without catalyst. Okay. Suppose I am using my positive catalyst, then what will happen? I told you that positive catalyst will increase the rate of reaction by decreasing the activation energy. So activation energy decrease means this dot will go a little bit lower. So this is in presence of positive catalyst. And one more thing I want to tell you, if there is no category of positive and negative in the question, always take positive catalyst, always. So whenever the term is catalyst, it means positive. Now the second is, if you have a negative catalyst, then I said it will slow the rate of reaction by increasing activation energy. So this is activation energy a bit up, and that is with negative catalyst. And positive catalyst means fast reaction, because rate of reaction will fast, so fast. And negative catalyst means slow. Any doubt, please tell me. This is very important concept, please tell me. Any doubt about this? Okay, suppose we have this graph. This is graph, potential energy and progress of reaction. Now first of all, tell me, what is this, exo or endo? The very first question, tell me. Very good, absolutely fine, endo, no doubt, because reactant and this is product. So reactant has lower energy than the product, means endo. And I told you that in previous slide, in equilibrium, if the graph is like that, reactant, product, it means endo. Perfect. Now listen me, here we have two transition state, one here and one here. Okay. So this is, you can say, transition state first, this is transition state second. It means this is multiple step reaction. Okay, two step reaction. This is the activation energy, and this is the activation energy as well. Can you tell me which one has higher activation energy, the transition state 1 or transition state 2? Yes, perfect. So higher means high energy activation means rate of reaction slow. Rate of reaction slow means this is slowest step. So this is slowest step. So this one will become fast step. Any doubt, please tell me. Any doubt? Please write down. Then we can move a question. Move to the question. Okay. We have this one. Look at the question carefully. Which of the following represents two-step endothermic? And second step is your rate determining step. Listen me again. Two-step endothermic and second should be slow. I got answer A. Please reply everyone. First of all, be comfortable to find endothermic out of all four options. Endothermic, which one is your endo? Tell me which one is your endo. First, tell me about endothermic. A, B, C, D. Tell me. A and B. Everyone is saying A and B, A and B, A and B. Why? Because if you look at A and B graph, the reactant has lower energy than the product. Means like that. Like this. Reactant has lower, then product a bit up. So this means endothermic, and this is only be present in A and B. Perfect. Okay. Now tell me, out of A and B, you know what is second step? Second means the second peak, not the first, second peak. So tell me, in which second step is your slowest step? Oh, sorry, there is a one more concept. Second step is rate determining. Here it is saying. It is saying second step is rate determining, and you know that rate determining step is always be slow step, always slow. So slow means high activation energy. EA should be high. And if you look at graph A, it is like that. Now you can see this is activation energy, the first step, and this is the second step activation, which is much more higher. So second higher activation means slow step, and slow step, this is the slow. And this is endo. Any doubt, please tell me. Please tell me any doubt. Answer will be A, not B. Okay? Because B, second step have higher peak, which is slow. Okay, try to find question number 2 again based on the same step. We have to find how many boxes is correct with the slow step. Listen me again, what is question? If you look at this is overall reaction A plus B, that gives C plus D. And they inform me that first degree in regard to concentration A means rate directly proportional to concentration A first degree. First degree means first order, like this. Any doubt about this information, please tell me. Any doubt? I think it's quite easy. If you look at these two lines, you can see this is overall reaction and this is my rate in which A is first degree means first order kinetic. And now you can see they have fast and slow steps, and this is rate determining. This is rate law. So this concentration should be present, concentration of A should be present in slow step. Slow step means the box will be correct in which slow step has A towards reactant side. Slow step has A in reactant. So left up my number 1 box, down number 2, this is number 3, this is number 4. Now if you look at number 1 box, the slow step has B and I only. There is no A. Can you see? Only B and I. So there is no A, which means this is wrong. Okay, now move to the number 2 box. You can see slow step has A. So this is fine. Now look at the number 3 box. Again, slow step has A. You can see fine. And now look at the number 4 box. Again, slow step has no A. So wrong. So we have only 2 box, which is the correct representation of rate of reaction. So answer should be B, because B has 2. Any doubt, please tell me. Please tell me any doubt about this question. My request to everyone, it makes sense. Perfect. Now I have another question. Okay, look at the 7 number. Question 7. Question 7 is, the conversion of a compound X into Z, it was found that the reaction proceed by a way of compound Y could be isolated. The step involved were X to Y, delta H positive. Delta H positive means endo. And Y to Z, that is negative. Negative means exo. And you know that if you have endothermic graph, then the graph's reactant must be lower and product should have higher heat, like this. And for exo, reactant has higher and product has lower, like this. So if you look at X to Y endo, X to Y endo is fine only in A and B. Can you check? Please tell me. X to Y endo, option A and B. Please tell me. Any doubt? If you have a doubt, let me know, please. Then I can proceed. You can see the graph of A and B. The very starting point, X has lower and Y has higher heat, which means endothermic. And it is possible only in A and B. Now move to next. Next is my negative, means Y and Z. So Y and Z means exothermic, and exothermic means reactant have higher heat and product has lower. So now you can see you can eliminate your option number B very easily, because B is again the second step is endothermic. Again the graph ends at like this, which is wrong. So only A is the right choice. Any doubt about this question? Please tell me. Perfect. So, you know, we have few points left still in kinetics. That is your like half-life, and second thing is your the activation energy Arrhenius equation basically. Okay, and few more questions as well. So in the next session I will organize very soon, and if you guys are interested, so interest is bigger thing for me. If you are interested, I will do again, and I will discuss kinetics, the rest part, and rest part of kinetics, the question only with some topic like Arrhenius, and I told you that. And second thing, I will discuss electrochemistry. In electro means we will discuss redox reaction, oxidation, reduction, and question based on it, Nernst equation, these kind of things. So if you really interesting in that sessions, let me know, so I will organize. Listen, I will do the pH one separately. Why? Because pH has a big content topic. This is a big chapter. So pH I will do this one alone. Okay, the pH, the buffer solution, Hasselbalch Henderson equation, and these kind of things. And my target is to cover everything before last February about general chemistry. So in that session, I discussed equilibrium and kinetic, like 90% part. In next session, I will discuss electrochemistry and thermodynamics I was thinking, electro and thermo, and after that the last will be your pH based and you can say acid base. So I am trying my best to cover everything before your last February, and in the first to 10 March, I will discuss only organic chemistry. That will be crash course. And in the next couple of days, I will discuss content with question. And the last 5 days, I will discuss only organic question, And if suppose some question has content or topic or concept, I will discuss that concept or topic at that time during the discussion of question. Make sense? Yeah, I have a physics expert as well, and he's one of the best expert. So I can provide you physics like log problems, question, basic mathematics, kinetics, these topics. So, I can provide you physics as well. Don't worry about it. Thank you so much, everyone. Have a great night. If you want to, say something, you can say. Yes, I provide private tutoring as well, but we are very close to March. So at this moment, I'm quite busy, but I can offer you for September sitting. I have already 4, 5 private classes in a day. So I can do only, couple of group classes in a week, and I will cover most of the content before your exam. This is my target. Thank you so much, everyone. If you have a problem with kinetics and equilibrium questions, send me and I will try my best to, solve that question. Thank you so much. Have a great night.